In your scientist notebook, go to the next clean page. This page will be the first page of our next unit. Put today's date at the top. Now, I want you to make a list for me on this page. You can use bullets or numbers, it won't matter. Make a list of everything you did this morning from the time you woke up until the time you walked into the school. Be detailed. If I were making this list, mine would be something like, woke up, looked at my phone, pressed snooze, went back to sleep, woke up again, looked at my phone, pressed snooze again, got up, went to the bathroom, washed my hands, brushed my teeth, went into the kitchen, made coffee, etc. Stop your list when you get to the point when you entered the building. Now that you've made your list, let's look at what you did. I'm going to show you some pictures. If you use any of the objects in the pictures, make a tally mark on your paper. How many did you use? Now think for a minute. What do all of these objects have in common? Right, they all use some form of energy. Think for a minute how different your morning might have been if your home had had no sources of energy. Now draw a line after your list. The next thing I want you to do is actually kind of hard. I know you've studied energy before and are probably familiar with a few different kinds of energy, but what exactly is energy? If a kindergartner asked you what energy was, how would you answer them? On your paper, write down your own definition of energy. You might start off by saying, energy is something that blah blah blah. What did you come up with? Here's what scientists say energy is. Energy is the ability to do work. In order to make sense of this, you also need to know what scientists mean when they say work. You've heard the word work your whole life. Get to work. Time to go to work. That was a lot of work, etc. Draw another line across your page. Now I want you to list 2 examples of something that you would consider work. Now let's find out what scientists say work is. Then we can look back at our 2 examples and see if scientists would agree with this. I have a short video clip to show you. In it, you'll see the official definition of work according to scientists. You should be looking for 2 things in that definition. Scientists say that there must be 2 things present before something is considered work.
To a scientist, work is only accomplished when a force moves an object some distance. A force is defined as a push or a pull. So even though someone may appear to be working hard to lift a weight, if the weight never moves, no work has been done. In contrast, if someone picks up a pencil and moves it to a new location, work has been done. Scientists use the formula work equals force times distance to calculate the amount of work accomplished. Naturally, to do any work requires energy. Energy is defined as the ability to do work. In the metric system, the Newton meter, or joule, is used as the unit of measurement for work or energy. So, if someone moves something with a mass of 20 newtons 1 meter, he or she is doing 20 Newton meters of work. Remember, work equals force times distance, or 20 Newton meters.
So this forces us to consider work in a different way, not as something that's a chore or hard necessarily, but as something that has those two things present, a force and motion. Scientists say something is only work if a force is used and something moves. Look back at your two examples of work. Would scientists agree with you that it's work also? Let's use this definition to determine if these examples are work. What about this picture? Is this work? Yes, he's pushing the dolly, and his legs, the dolly, and the boxes move. But what about this one? How do you know? Yes, in order to dunk a basketball, you have to push off the floor with your legs, pull the basketball up, and push it through the hoop. Your body, the ball, and often the basketball rim move. But what about this example? Is this work? How do you know? If you said yes, you're right. There's a push away from the Earth caused by the explosion from the shuttle launcher. The spacecraft moves as a result. It's a lot like how a balloon works. If you've ever blown up a balloon and didn't tie it off but then let go of the balloon at the end, you probably noticed that as the air rushed out of the balloon moved wildly in the opposite direction. This is how rocket launching works. We have a controlled explosion out of the bottom of the rocket, and it forces the rocket in the opposite direction. It pushes itself away from the Earth so that it can get far enough away so that gravity's pull doesn't pull it back down to the Earth any longer. Notice that it doesn't have to be a person doing the work. It can be a machine. In fact, that's why we invent machines, to make work easier and more efficient. So let's review. Energy is the ability to do work, and work is only accomplished when a push or pull is used to make something move.